How to transform and deform 3D objects. Hello everyone, in this video we're going to discuss everything you need to know about object transformation and deformations, also known as linear and nonlinear transformations. We're going to illustrate how to use it on complete objects and on sub-elements from an object. To get started, I'll go to my 3D shape tool and I'm going to use a basic cube, click on it. First thing you see is that the cube by default gets positioned onto the center of the scene. And the default, if you click default values below, you see this, the default settings, has a size of 100 by 100 by 100. This is cubic, it's from all sides even, it's 100 by 100. Okay, once I finalize this, basically you have the mesh over here. You can start deforming them anyway. I can start the entire object, start moving and rotating and scaling all of this, or you can select parts of the object, let's say for example just a face, and start stretching them, or go to scale and start scaling in one direction or another. You cannot scale in the height because there's no height to it. It's a zero value. And this is what I'm going to explain now how actually this is working. So I'm going to click undo to undo back to the original size. I'm going to turn off my face selection, easy to work with. And to illustrate how these things are working, I'm going to create now a cylinder. The first thing you see in a cylinder, actually my object is no longer the center over here, the cube, so it overlaps. I'll position it first back, the cube to the center. To position the cube back to the center, I need to go back position to make it 0. You see position here is -14, -2. I can type in the values over here, or I can just double click on the move tool, which will center it, or you can just click once and then click center. The object would be centered. Now you can see the value here, 0, 0, 0, same way as just manually typing them in 0, 0. Okay, going back, if I go to the cylinder to create a cylinder, now you see the cylinder fits in the exact same size as this, the default value. If you click on default values, the default value of the cylinder will fit into this box. But strangely, the size is actually 50 by 50. And the reason for that is because a cylinder or any cylindrical object is using basically a radius as a measurement, and radiuses have a size. So a radius of 50 is technically a size of 100. So once I finalize the cylinder, you'll see actually the size is 100 by 100 by 100. Same way, if you enter the scale tool, you'll see it's 100 by 100 by 100. Okay, so let me explain how the measurement is actually derived. So if you measure a 3D object, you may think we're actually calculating the volume of the object, something like that. But from a volume perspective, this is not the size. You have to think it's impossible that the size of a cylinder and a cube is the same size. If you look at it, the cube actually has a lot of extra volume, so additional volume. And the truth is that we don't actually calculate the volume. Most 3D modeling software will go with the same concept, that we use something that is called a bounding box. To illustrate what a bounding box is, I'm going to select my cube and I'm going to go to the edge mode, select edges. And instead of picking a single edge, I'm just going to go to the edit mode and go click select all. So I'm selecting all edges. And now I'm just going to go to click copy and copy that. Once this is copied, I'm going to delete, select again the cube, and I'm going to click delete to delete the cube. So now what I have here is a simple box. This box is something of profile, which hopefully we'll get to it in future videos explaining these concepts. For now, all you have here is, you can see we have a box. There is just a wireframe kind of, similar to what you click from here. Wireframe is just edges. And we can see that this wraps around tightly the cylinder, meaning is, if you think about like packing, if you want to order a shipping box and put into it a nice cylinder in it, if you need to measure the size of the bounding of the box of the shipping box that the cylinder will fit in, this will actually be the size. You need a box that is 100 by 100 by 100 to fit in a cylinder which has a radius, top and bottom both same radius of 50, which is technically the size of 100 because the bounding box size is 100. Now the interesting thing, what will happen if I'm going to rotate this object? I'm going to rotate this object and I'm going to rotate it by 45 degree. The x-axis, 45 degree. If I rotate this by 45 degree and then I go to my scale, or look over here, the size in the bottom, you see that the values changed. I have a size of 100 and the x has not changed in the x direction. The x direction is, if you look over here on the bottom right, you see the axis, the x, and the x-axis, because the cylinder still fits into the box in the size. It doesn't stick out from the size. But if you look at it from the other directions, in the z direction, it sticks out equally on both sides a little bit. And the combination of both sizes would be 141, we'll look in a minute. But the top in the Y direction, it sticks out entirely just from the top, nothing from the bottom. What sticks out from the top equals to the same amount that sticks out combined from my right and left, which is basically the front and back sides. So first of all, how is this happening? Why on top sticks out the entire thing, and over here and front and back, or to my left and right, it sticks out just half here and half here. Before I go into this, explain this, I want to show first how I can actually position this and how this is measured. So the way this is measured is, if I go back to my cube example, this box example, I'll go to the scale tool, and I'm going to scale this up. I'll click on the Y and Z because these are the two that I need to change. I want them to change together. So 141.4, that was the value. And you see over here, once I typed in these values, it updated both of them. And now we can see that we have a box that actually tightly fits this. Meaning is, if you want to put in a cylinder to a shipping box in this exact angle, this exact direction, you'll need a box with that size. It's not because the volume of the cylinder has changed, it's just because in this direction, the way to position it in a box, you need a bigger box. That's basically the size of the box. In technical terms and 3D modeling, this is called, and same for gaming and other stuff is used, this is called a bounding box. Kind of, it bounds around something that wraps around the object. It's a very quick way of calculating measurements, and it's not actually very accurate, as you can see. So there's other measurement tools to measure more accurate, specifically the measurement tool from the utilities. Actually, measurement is, I forgot myself, measurement, yes, it's in the utilities. In utilities, you have a measurement tool where you can do different things, but that's not the scope of this video. So now going back to the problem, how I'm going to just undo both of them. Why is it that it sticks out from both sides? And I'm going to undo the rotation. And what's happening here is that SelfCAD, or actually let's redo it just to explain it. SelfCAD does not allow to go outside of the grid of the workspace. It constrains it, everything, and I think that was explained in the previous video as well. It makes sure that everything stays within its workspace, and if you need to have bigger, you can increase it from the workspace settings, change the size of the workspace. So if you would want to do it and both ways stick out, you would need to lift up the object. So basically I can select both objects and I'll raise it up, let's say 50 from the bottom, something like that. And now I'm gonna deselect the cube and rotate just this, the same value. And I'm gonna rotate this by 45 degrees again. And now you can see it sticks out equally from both sides. Interestingly, the actual value, if you remember, we had it before 141.4. This will actually be changed now also. It's 141.31. And the reason for that is because we don't really get exact volume, same as I said before. We actually just take how much it takes to position the object in a box. And in this case, once it's positioned higher and equally from top and bottom, they are actually the center of both of them. Somehow this is by a fraction of, which is kind of like by points, by 0.9, something like that, based on the way the cylinder is positioned. This may also be sometimes when you measure a size of something, every object is made up of 2D pieces. So this cylinder is made up of a lot of 2D faces, 2D segments, and depends on how smooth it is, how many segments you are, this is how big each 2D piece is. But it's a great difference when you stick them out, the place where you measure. So to illustrate that, for example, you can measure, take the measurement tool and you can measure from point A to point B. This may be 99.92. It's even if I snapped it to these vertices, because they're not 100% rounded, especially when they don't have enough segments. So, but yeah, so that's basically the concept over here. So now let's see how we can actually make use of this and how this is working. To have a more practical example, I'm going to go now to the plane, the tool that is called, the shape is called plane, and a default plane has nothing. If I finalize this, you go to the wireframe mode, you can see it has only these edges, basically this very limited, you can see. But I'm going to delete that and go back to plane. I'm going to change it. I'm going to add segments now, let's say 7 by 7. I'll leave it, the default size of the plane is, the width is 200 and 100. I just want to show here something that working in any application is not related to 3D. This is related to the way web application or widgets or whatever these things are working. When you work with sliders, you have to have a value of something, minimum and maximum, and there's sometimes difficult how you do that. So usually you have some value. In this case, you see the value is max 200. That does not mean you cannot make it bigger than 200. If you click on it, it tells you you can type in the value. If you try to do more, let's see again, you see the message, you reach the slider limit, type in the value. So if we're going to type in, let's say 300, it will still work because now I typed it in. I can type in even 500 and this will still work. If I type in more than the value, my size of screen is 700, I'll have a problem. So let's say if I type in 800, it will jump back to 700 because that's the size of my screen. And unless I update the size of my workspace, increase it, we're not going to be able to do it. So let's go back now to 200, and I have that entered 7 by 7. Okay. So what I'm going to do now here is I'm going to go to face selection. I'm going to select these faces, and I'm going to make a pattern. Now I'm using now the basic way because this is an introductory video, but SelfCAD has actually tools in the advanced settings. Advanced selection, advanced setting. Every time you have a SelfCAD tool, you can find more advanced things in advanced settings. And if you go selection over here, you have advanced settings. You can find tools that can actually help you select these easier loop selection with custom patterns and stuff. For now, what I'm going to do here is just select it. If you look at it, if I ask you what will take to put in this to a box, this entire selection, the answer is it will take the same size because I selected the entire boundaries from here to here, and the same at top and bottom. So if I look at the value here, the value is 200 by 100, which is the same size as the entire object, despite the fact that I've not selected everything from the object. So this is where we can actually have here a value that it's called individual transformations. And this tool in the advanced settings are always dynamic features depending on what you have selected. This will only be available if you have selected parts from an object, or we call it often region selections, which could be selecting a region based on faces, polygons, edges, vertices, and this type of stuff. So if I turn on now individual transformations, you see the values over here change to 0, 0, 0. I'll come back to that for a moment and see how this works, whatever. But now I'm going to enter a different value, and I'm going to change the value in my x-axis. Again, looking at these bottom right axes as a guide, so I see in which direction I want to make it, and I'm going to change that to 5. So now what you see over here, I changed the value that each of this individually would be 5. So technically what happened here is, when you turn on individual transformation, we make a bounding box for each of these selections separately, and you cannot enter the value of them unless you give an average value, because this may have one value, and in this particular case, each of these have the same value because they were created symmetrically in the same size. But you often may select things, large faces and small faces and do individual. So it makes no sense to show the exact value. But when you enter that, what will happen here is it will say that each of these bounding boxes should be changed to a certain size. And based on changing the bounding box size, we're actually changing the object. And this is the same way when you select entire objects. We actually scale the bounding box. It doesn't really matter actually if technically scales the bounding box or not, but it's kind of the same concept. We measure the value based on the bounding box, and we scale it in such a way that actually the bounding box scales as well, and individual, it will scale each one individually. Okay, now this is also the reason why you cannot actually scale in the other direction. So you cannot, even if I turn off individual transformations, you'll see I have a value here of the X direction, which now, because I made them smaller, their total size is less than 200. But the Z direction is 0, and there's no gizmo here. I cannot scale in the Z direction because there's nothing to calculate here, a bounding box or something, and actually, technically, you cannot scale them. I have here, you can see something, I have turned on my coloring, backface coloring, which basically shows me this is the inside of the object. There's basically, and this is a different topic, we'll discuss it in the section when we discuss the modify tools. But this is basically just a single 2D thing. You cannot scale something that has no thickness, but in other directions you can scale them. Okay, now what we'll do over here, I'm going to select the same thing but in the other direction. I'm going to select the pattern over here. Now you see I actually use the marquee selection. You can use it simply by using your mouse, drag and drop, or you can turn it on from here. There's an option marquee selection, and it's the same thing. Now you can just click, even left click. I don't have to right click. Like normally without this turning on, I have to right click to drag. And with this turned on, I can use the left mouse to turn it on. This is basically my key selection. But in both of them, you see if I click from left to right, nothing is being selected now. if I click right to left, it is being selected. And this is a default behavior in most 3D modeling applications, that there's two things, and whenever you want to select something, there's a concept you want to select everything that is partially intersecting in my lines. You see, if I drag over here, I didn't really intersect the complete face. Intersect meaning kind of, yeah, basically, I'm not sure any other word to use it, kind of like overlapping this face, okay? It's called intersection. I'm not choosing the entire face. In some cases, you want to select everything that is partially in it, and in some cases, you want to select only that is fully intersected. So for example, if I'm going to drag it more down, partially intersecting the second one, it will select the top row, not the second one. So what's happened here is that SelfCAD has two modes, and as I said, this is the same behavior in most other 3D modeling applications, that when you go from left to right, it will select only that is completely intersected, and if you go right to left, it will select even partially intersected. So in this case, I'm going to have over here, it's easier, oops, let me undo this. Okay, so I want to select the same pattern over here, but make sure to fully intersect only the ones that I want to select. And I do something like this, and I'll go again to my scale tool, and I'm going to use individual transformations, and I'm going to type in the value now in the Y direction, the height, same thing, 5, that I want this to be 5. Okay, so now I have this selected. I'm going to select these faces over here, and I'm simply going to delete them. Click delete, and that's it. So now I have here a basic shape of, you see, you can make like an office table, something like that, but it still doesn't have any thickness, nothing. So I'm going to go now to a tool, add thickness, and we're going to add thickness to it, let's say -100, and finalize it. And now you see we have a basic desk created using that way. So again, add thickness and explaining these tools are in the section where we discuss hopefully modify. But what I wanted to show here is mostly the concept that transformations can measure basically based on the bounding box entire object or measure individual pieces, and you can use it in the same way for entire objects or anything else that you can select. But nevertheless, whatever you select, whatever transformation you do, it's the same for the entire object, which is also known as linear transformation, meaning the entire object. If I move the entire object, everything moves in the same direction at once. If I select pieces of the object, let's say just a face, I can start deforming the object, and this is not because I'm using a deformation tool. I'm using a simple move tool, or if I'm going to scale this and make this smaller and kind of start playing with this thing, it's not because I'm deforming the object using the deformation tool, it's just because that I've selected parts of it, and if you stretch only parts of an object, naturally it's being deformed. When it comes, however, to the deformation tools, they are non-linear. So in order to illustrate that again, I'm going to use a basic shape to illustrate another example first and transformation tools. So I'm going to use again, I guess I can use again the plane that I've created. I'm going to use just segments like this. The height segments I'll leave, and the width segments, maybe I'll make this 10 segments, and the width segments I'll leave it to just 1. Okay. Now what I'm going to do here is I'm going to select edges, and I'm going to select, instead of selecting all, I'm going to select just these. Basically, actually, this also maybe. I just don't want to select this faces over here. And I'm going to click copy. So now I have these edges, and I'm going to isolate this so it's hidden the other one. Okay. So now what I'm going to do here is I'm going to select these vertices over here, all of these vertices, and I'm going to go to the move tool, simple move tool, and I'm going to move them to, or I can rotate them actually. Actually, I think rotation will be better over here. I'm going to rotate them around the y-axis, which is kind of around in this way, if you see the y-axis over here, and I'm going to rotate them, let's say, by 5. So what happened here is, you can barely see, actually, there's nothing here I can rotate because I selected, yeah, this is not going to work. I have to select the edges actually to do this example, because you cannot really rotate, yeah, you cannot rotate single vertices. It's just not going to work. I have to select the edges. So now I'm going to rotate them by 5, and you can see we start moving it a little bit. I actually want to do it rather -5, so it'd be better. I'll make it -5, so rotate a little bit. What I'm going to do now here is I'm going to deselect the bottom one, And instead of typing in again the value, I'm just going to make repeat. I want to repeat it. I'll deselect and I repeat, deselect and repeat, and deselect and repeat, and so on and so forth. As you can see, what happened now here is that I'm actually deforming the object, and it's something that's called non-linear, meaning is each one has a different value than the other. And the way I'm able to do that is because once I deselect and I repeat, meaning is that each one multiplies. So if you think about what's happening over here is that I got this shape. Now I can actually go and fill this in. So let's say if I'm going to go to draw now, let's say a spline to connect them, but yeah, this is not the actual scope of this video, but just to show this quickly, I can kind of complete this, and now I have this drawn, which is this shape. And again, this is not the topic of this video to show how you can fill a shape like this and actually turn it into an object. But what I want to show here is that this requires something non-linear, which the first one was moved by 5, the next one by 10, the next one by 15, next one by 20, and then 25, and so on and so forth, because every time I repeat the previous transformation, and this ended up in something like this. So this is where deformation tools comes in. In the case of deformation tools, let's get rid of this, and let's take again this original shape. What will happen here is that I can go to deform, and I can go to twist. And a twist tool will basically allow me to simply twist it, and that's all it's doing. I can twist that by the value that I can figure out that needs to be twisted by, and that basically does the same thing. It just twisted it the same way. And what a twist is doing, it's basically a rotation. It's just that it rotates based on a certain value. And obviously if it's based on a certain offset value, like where it rotates the most, so for example the same idea we had before, it rotates the most on the top. The bottom is the minimum and then top is the maximum. You get a similar idea. But sometimes you want to rotate it differently, and this is where the advanced settings again comes in helpful. You can add obviously minimum step size, make it easier to position. This is available in all tools, but you can position the origin. So let's say I want to make it the center, but I want to make it, instead of the bottom, I want to make it in the middle. So if I'm going to rotate it now, I'm going to get a different behavior, because the minimum now is the center, and now it rotates top and bottom the same way with the same offset from the center, and you can actually make it manually position it and so on. There's different tools that have even different behaviors. If you think about the bending tool, it's a similar idea. All of these deformation tools are actually a combination of basic move, rotate, scale. This is all transformation you have. They're only non-linear, meaning is each part is moving differently. And in this case, if you look, let's say for example, bending, I can bend. Bending is different than rotation. It's not bending around something, it's towards a direction. So if you've seen the z-axis, for example, I'm going to bend this in this direction, this kind of bending it in this direction. But it also depends, the same idea explained in the previous video, that everything works with planes where there is. So here you have additional settings. You have, like, first of all, you can choose the top, bottom. You can choose first of all this, let's say from the center. So I want to make this the center, I want to make this the center, same way as I did before with the twist. And now you can see it bends from the center, okay? You have some other unique settings to bending, which is something called dynamic origin. And this is something that allows it to, it's a complex thing to explain, but basically what happened here is if I bend this, it keeps on changing. Even if I bend this in the z direction by 360 degree, which should kind of close it, okay, it's still not closed perfectly. And this is because the way it's being calculated, it keeps on offsetting the pivot point automatically. So dynamic origin will make sure that it offsets in a way that I can close it. So if I make now, let's say 360, you can see it's perfectly closed. And obviously this is, I need to add thickness to it, but it's a different concept because I have only one side of it. But it's basically what dynamic origin will tell you. But the most other thing here is that you can choose a different plane. This is similar concept to what I've shown in the previous video, that you can have a custom direction. Custom direction is a relatively new feature in SelfCAD, and very few software actually have that. And before that, we had in Bend tool the custom, like you choose a different plane. So if you choose, for example, this plane, there's nothing you can bend in this plane because this is a 2D object. In this plane, you don't have anything. In this plane, you have something, but it's a different direction. So if we're going to bend it like this, this will kind of behave differently. There's no thickness to bend in this direction. and over here you can see I can kind of bend it like this. So this is kind of on what plane you are bending. It's basically which direction, which plane you're using. To actually illustrate that, let's go and add thickness. Will be easier to see that. So I'm going to add, let's say again, -100. So it's now a complete object. I'm actually not going to be able to bend it in all of the directions, because in order to bend them you need more lines, edges. So first of all, let me show you this. So if I'm going to go first resolution, there's an option to go to 0. So basically I have nothing in it. If I'm going to bend this now, regardless which tool I'm going to use, which direction I'm going to use to bend, this will just skew. It's not going to bend because there's nothing here that can actually bend, only top and bottom. So it's the same way like skewing the object. But if I'm going to add resolution to it, let's go to resolution, and I'm going to add, let's say, 2, 4, adding some details. Now I can start bending this in this direction. And now if I choose, let's say, the different planes, front and back plane, now you can see I can bend it in this direction. Okay, and if I can choose, let's say, left and right plane, I can bend it in this direction also. It bends like this. So these planes actually, you see I'm going in the same direction, the blue axis and the z-gizmo, but because I'm using a different plane, it behaves differently. It may eventually be replaced, this option, with custom direction, based on feedback, because this is an older version and we have recently added the custom directions to all of the transformation tools. But nevertheless, this is quite helpful. So if you look at all of these transformations, in case if you look in Fillet, for example, it's the same concept always, that it's a non-linear transformation, but it's basically using all transformations, it's just applying them in different patterns, and you always have to look at advanced settings to try to see what options you have. In this case, I'm going to select, let's say, just polygons, and this is no longer flat, so it's no longer a polygon. So let's go select over here, or parts of an object, regardless which way you select. And you can inflate, for example, just parts of the object without inflating the other parts of the object, and this is basically how you can always work with segments. So the same way you can in transformation use just parts of an object, same way is in all of the deformations, you can work with just parts of an object, but it's always limited to what you have. For example, if you're going to take a single vertex, there's nothing you can do. You cannot inflate a vertex. There's nothing else to offset it. The same way you cannot scale something that is just one plane, you cannot scale it in that direction because it's 2D. There's nothing to make bigger. You cannot make something 2D bigger. You can add thickness to it and then make the thickness bigger, but something that is flat, just 2D, you cannot scale them. So always you have to be mindful on it, and the main idea what you have to be mindful is that an object has to have some added resolution, I mean, so you can basically have what to work with. So that's basically it here. There's one additional thing that I wanted to show. I showed before that when we select multiple segments, we don't have actually the measurements. Once I go to, for example, this and this, 2 segments, if I go to scale, the size would be all of the sizes, but once I enter individual transformations, there's no size because technically they're 2 different sizes. The only way to show something is an average, and it doesn't really make any sense to show the average between them. However, SelfCAD has another tool that actually does that. So to show you that an example, that's basically the coloring tool. So if I'm going to change the color, let's say from this object, let's say whatever, any random color, you see whenever I select a color, it shows me over here the color. And if I'm going to select this color, it's going to show me this color. In the same way, if you enter them, you will see, you go to the picker where you can enter values, you can see the actual hexadecimal color and the RGB color or whatever color you're using here to enter the value. Actually, it looks like it's the same, just a hex color that shows you. RGB shows over here. You can see the RGB read over here, and this is the HSB, and this is the hex color that you can use to type in. You can also use, by the way, a picker to kind of click on something and say change it to this color, but I'm going to cancel it. I don't want to change it. Okay, but what will happen if you select 2 objects together? In this case, we have the same problem. You cannot show either this color or this color. So the other option is to show nothing, like we do in individual transformations, or we show the combination. In the color picker over here, we show the combination. So it's actually quite interesting. If you want to get an average between 2 colors, you can just select 2 colors, and then you get the hex value or RGB or HSB, whichever value you want, and then you can use them to make another object which has a combined color. Lastly, the last thing is just another transformation idea, that the same idea is not just in parts of an object, same with the entire object. And SelfCAD actually shows the bounding box, just the bottom of it. You can see over here this rectangle that is shown over here. If you're going to click on scale now, you'll see this is a huge size. It's 380 by 154 by 160, and this is the size of the entire thing. If I'm going to deselect this, you see the size just of this, and if I'm selecting this and deselect this, size just of this. And what I do now here is actually an interesting trick. In most cases and most tools in SelfCAD that has a check mark, you need to confirm something, you'll be limited to what you have entered. It's a selection first application, meaning you select first something and then you enter and do it. But in some tools like these, there are tools that you can make changes in the middle. So if you deselect everything, the tool will close. So if you want to work with something like I did before, keep on repeating transformations, you can just select one object, and if you enter the tool, then you can select the next one and then click again on the first one to deselect them. And that's how you can keep on playing without really closing the tool. That's it for now. I hope you like it, and I'll see you in the next video soon. Thank you. Bye.